Okay, question 4 is about electrostatics. So a student's got a rubber balloon, so we know that's an insulator, and it's tied to a long piece of cotton thread. The student gives the balloon a charge. Describe one way that we could do this. So we've learned about charging by friction. So ultimately we've just got to say, get yourself an insulator, rub it, and then this will move electrons from one to the other. So in terms of here, we're going to do charging by friction, rub the balloon with another insulator, for example, a cloth. And the mark scheme just says rub the balloon with a cloth or an insulator or fur, any insulator. Okay, the student gives the balloon a negative charge. So if that's the case, there's the cloth. They would have started neutral at the start, plus, minus, minus, plus. And then for the balloon to become negative, we know we can't move the protons inside the nuclei, but we can move the electrons. So that's how we did it. So this has now become plus. This has now got a net negative charge. So we can see that electrons have been added to the balloon, wherever that one is, B. Next one, the student charges another balloon on a long thread. And I think it would have been useful for the exam board to just put that in bold, because the third mark on this is pretty tricky actually. So what we've got to do is explain how we can show that the balloons have the same type of charge. Well, we know that if the balloons have, say, the same charge, they're going to repel. But the crucial part is understanding, why do we have to put these balloons on threads? And what it is if I was touching the balloon directly with my hand, and then that hand, oh my God, sorry. If I was touching the balloon with my hand, now let's draw a proper stick man. It's pretty ropey as well. Let's get that ready there. And us on the floor, we're going to discharge to the ground. But if I have the balloon on a string, this is going to act to insulate the charge from moving, so it doesn't discharge and go to ground. And that's the third mark. The other two are easy, but that part in terms of why on a long thread, that's to avoid discharging the balloon. So bring the balloon together on the strings, and then you've got to mention in there so that they are not discharged. The balloons should repel each other if they have the same charge. So bring the balloons together, mark, they should repel, but that part on strings so that they're not discharged is a trickier mark. Okay, so we've now got a plastic block and a metal disc, so we can see that there. The plastic block's negative. We've got a metal disc and an insulating handle, and this is all going to be about charging by induction. So that's the idea, that if so positive negative comes up in loads of different ways, but we've looked at it before in terms of a balloon, and if it had a net negative charge, as I bring the balloon close, it'll repel the electrons backwards into the wall, and then the positive charge at the front will attract that, and the balloon will stick to the wall. So we've got another example of charging by friction. So it said, which of these diagrams show how the charge is distributed? So we know that this negative charge is going to move electrons back, and there should be a positive charge at the front. So we're looking for that, where we've got a positive charge here and a negative charge at the back of the metal disc. So it's definitely not going to be A. And B seems to be working pretty well. There's the negative charge from the plastic block, and we can see it's pushed the electrons back. So the answer is B. The student keeps holding the metal disc above the charged plastic block and taps the metal disc with a finger. This earths the metal disc. Explain how the disc now has a positive charge. Well, if we've earthed it, the electrons have moved to the ground, and that's it. So it's this idea that we've kept it on, or when it was the balloon, we kept it on a piece of string to discharge it. Now when we touch that plate, we've discharged it. So electrons will flow from the disc to the ground. And we've got that idea of from and to. The next one, this shows the charges on the disc, and we can see we've got opposite charges, and I've taught you pout and nin. Draw lines to show the shape and direction of the electric field. Now this is going to be a uniform electric field in just the same way as I've taught you with a magnetic field. North, south, draw 3 lines and move them north to south. We've got to do the same this time, but using our pout and nin. And don't draw any more lines than 3. It's 2 on the edges and 1 bang in the middle, like that. And there we go, it's 2 marks. So you've got a mark for it going from positive to negative, and 1 for showing it's a uniform magnetic field. Electric field. Done.